Hello guys, first of all a very warm welcome to everybody who is present here in this session. As per my calculation, I believe like 60% of the people to whom we send the invite are present here. So it's pretty good numbers that you have come up. So thanks a ton for coming for this session. Now as I know a lot of you and as I work alongside some of you, I know that you guys possess very strong technical repertoires. So with so many intellectual brains under one roof, I believe this session is going to be a gem of a session. Now, I also perceive that you guys know about me. But for those who do not know about me, I'm just going to reveal a certain secret. The secret is, they call me a man with a fancy beard and they name me as a Wolverine. But do not expect my fleshy knuckles to come out of my knuckles or my wrists. Now, let's quickly shift our focus to the agendas that we're going to discuss today. The two topics that we're going to discuss today are DevOps and Docker. But before that, you might be looking at a couple of symbols at the bottom and thinking like what they are. So the first logo is for Paxel and the second is for Boxer. I think most of you refer Paxel as Paxel Technologies, but thing is like I prefer to refer it as Paxel Labs. The reason for that is that you get ample opportunity, ample time, and you get consistently backed up by the team management as well as your project managers to do certain sort of researches and come up with a project or a product which is an innovation and which can be set as a benchmark in the upcoming future. Now, as a result of one such innovation is the product named as Boxer. We have recently released this product, Boxer. So you might be wondering what exactly Boxer is. So just to give you a brief introduction of what Boxer is a tool which primarily helps you create virtual machines. And it harnesses the power of very famous tools like Puppet and Vagrant. Okay. I would not like to go too much off record and come back to the main agendas that we are here today. So the two main agendas are DevOps and Docker. Okay, so these two are the two big Ds of the IT industry today. And these two Ds have created a B. Now if you visualize and collaborate two Ds, it forms a B, right? So the point is, like these two technologies, DevOps and Docker, have created a lot of buzz in the IT world today. Okay, so for those who are not aware about the term DevOps, I would like to give you a brief introduction and a brief case scenario of what DevOps is. So DevOps, number one, is not a dictionary word. It's a portmanteau. Portmanteau means a combination of two words. So it's Dev stands for development, Ops stands for operations. Now if we quickly jump into our time machines and get approximately 15 or 10 years back, this was the trend or a case scenario that you will find in the IT industries. Dev would be on the one side of the ball and Ops is on the other side of the ball. This shows that there was minimal collaboration between Dev and Ops. What Dev used to do is, they basically used to code their applications and then volley the code above this wall to the Ops team. So when they used to volley their code, there was minimal collaboration between development and operations, right? So this led to a lot of issues, and the one prime issue that used to come up was, it's working on my machine, why the heck it's not working on the deployment environment, right? The reason for that was very less collaboration between Dev and Ops. Now, since the DevOps culture has evolved and since the DevOps processes have come into picture, this is the scenario or the trend of the today's IT world. So these two initials have collaborated, the walls have been broken down, and the thing is like Dev and Ops are working in a cohesion, and the thing is like they're working in collaboration. What it does is, it basically automates a lot of processes, it basically simplifies a lot of processes. The two main agendas which DevOps preaches are automation and collaboration. So it's not a process, it's a cultural change which every organization is looking forward to, and the thing is like they want that this should be a part of their process. Okay, so this was brief introduction about DevOps. Now let's quickly jump into the second D that we saw on the first slide, and the second D is Docker. So what exactly Docker is? Docker is a tool which is built on the shoulders of the DevOps domain, and the thing is like it helps you create Linux containers. So it's a kind of a wrapper or a service, and it helps you create Linux containers. The point about Docker is it helps you create very lightweight containers. You snap your fingers up and you can set up containers in the cloud or any production environment wherever you want to. Okay, so this was just brief introductions about DevOps and Docker to give you insights about various technologies, various terminologies like virtualization, Docker. How can you provision your Linux containers with Docker? I would like to invite on stage Avinash Singh, who is the DevOps engineer with Paxel Labs. So please Avinash, the stage is all yours.
Hi, today we are going to discuss about introduction to containers and Docker. So before getting to discussion, I would like to know that how many of you are currently working with VMs? Okay.
Mostly all of us.
Okay. How many of you know how the VM works? The basic idea of how VMs are being hosted on one physical server? Okay, quite a few. Thanks. Let me show you how the VM works. Actually, as far as we know, that VMs are being hosted on one physical server and they run in isolated environment. Let me show you how it actually works. In the case of VM, we have a bare metal hardware on the top of which we have OS. This is a physical OS on bare metal hardware. Okay, on the top of which you have a hypervisor. This hypervisor is a software which acts as an emulated hardware for the virtual machines. Okay, and on the top of your virtual machines you have your libraries and applications. You can have multiple VMs on a physical server with the help of hypervisor. So this is a pretty high overview of virtual machines, how actually virtual machines work. Now let us consider a scenario where we remove a hypervisor and OS and you are left with your applications and libraries. Doesn't this sound a bit of light? Okay. Welcome to the world of Linux containers. Okay, as the definition in the slide says that containers are the lightweight virtualization technology that provide a free software virtualization system for computers running on GNU Linux. It uses the feature of Linux kernel of namespaces, ch roots and c groups, which allows you to run multiple Linux containers in isolation on one physical server. Let me show you how they are different from the existing virtual machines. As we have discussed, that in the case of virtualization, there is a hypervisor and a layer of OS on top of which you have your libraries and applications. Now, in the case of Linux container, we have the same layer of bare metal hardware and OS. Okay, and on top of which your Linux container is being running using the Linux kernel features, namespaces, C groups, and CH roots. Inside your Linux containers, you are only left with application and library. It is very lightweight. But now you might be thinking that where the Dockers come in picture. Actually, managing a Linux container independently is very painful, as because there is no standardization. Docker gives standard to Linux container. Okay, let's see what Docker is. Docker was actually a project which was being created by folks at .cloud in Jan 2013. Since then, Docker has grown itself and it has a very active community you can find over there. Let's see the definition of Docker. Docker basically is an open source LXC project which is being released in March 2013, which helps in creating lightweight, portable and self-sufficient containers. Okay, now let's see how it actually works. Okay, we have jumbled few boxes and to put in the picture together to show you how Docker works. Okay, when you install Docker, you get a Docker client, a Docker daemon and a lib container. lib container. Lib container. Yeah, please replay the slide. Okay. When you install Docker, you get Docker daemon, Docker client, and a lib container. Okay. Let's suppose you have to create a Linux container. Then you have to get a specific image. You pass your command to Docker client to Docker daemon. What Docker daemon will do is that check that the existing image is whether available on your local registry or not. If it is not available, then it will pull from the cloud registry and push it to your OS. And through the lib container, using the features namespace and C groups and CS groups, it will contain your container in which you can write your codes, your applications and library. So this is pretty high level diagram of Docker, how actually it works. We will also have a demo of Docker. Before getting to a demo of Docker, we would like to show you the installation steps, but installing Docker is very simple. I will not show the installation steps because they have done a great job of documentation for installation of Docker. But before getting to a demo, I would like to discuss few terminologies which we generally come across using Docker. Images and container. You might be thinking, what are images and container? Actually, images are read-only snapshot and containers are the images in execution. This will be more clear from the example which I am showing. Let's suppose you have a piece of software, okay, basic framework, and you have pushed the code to a Git repository, which is a center repository, and you have 3 team members, A, B, and C, and they have to add their modules on your, they have to add their separate modules, okay. Let's suppose team A pulls the code from the Git and adds his coding to your existing code, then it will not affect to the code of team B and C because they are being running in because they pulled the code from isolation. So you might be thinking how this will work in the case of images and container. In the case of images and container, images is a read-only snapshot copy, and if suppose container A is using this image, then and adding some commands or adding some libraries, then it will not affect the container B or container C which is using the same image. Okay, and same is the case with container B. If container B is using writing any command or installing any packages, then it will not affect E or A or C. Now let's jump to the quick demo. I hope that this jumble of diagrams have helped you to understand the basic idea of container and images. Let's have a quick demo. So we have installed Docker on our server. Let's see what Docker commands do. Just simply write Docker. Okay. What you are seeing over here is that Docker gives you the list of commands available to you. Okay. Now we will run a simple command to check the version of Docker we have. Okay, it shows the version of our Docker. Now let's suppose you have to search any image available on your local repository. Then just you have to type Docker images. Yeah, it will show you the list of images available in your local repository. Okay, let's suppose if any image is not available over here and you have to pull it from the registry, pull it from the cloud, then you have to simply run Docker pull command. But before that, if you want to search any images named as CentOS, then this is as simple as this. Docker, just write search CentOS. It will take time. Okay. Basically, it is searching on the cloud. It will show you the list where CentOS is being typed. Okay, we have the list. This list this list is on the cloud and has been fetched from the cloud to your local system. Okay, let's suppose we do have a lottery system over here. Which one you would like me to pull? Okay, we will pull this one. Okay, thanks. suppose this. Okay, this is pulling from the registry which is sitting on the cloud. Okay, it will take a time. Let me show you other features of Docker meanwhile. The next tab I have opened. Okay, let's do a hello, Docker hello. Okay, I have created few images. This is one of them, and what I am going to do is that I will run this image. I will run this container in background. Okay, and I am exposing port 999. Okay, I am exposing port number 80 of the container to port number 999. Let me show you. Just we have to run this simple command, and we are good to go. Okay, the container is running. We may check the status of the container. Docker. Yes. Okay, it is running. Actually, as the name is suggesting that it is BoxUp HTTPD version 1.0. Actually, we have made a container. Actually, we have made an image, and what we have done is that we have installed Apache in it and started Apache during the container startup. If you can see the URL, okay, what we have done over here is that we have also forwarded showing that your base machine port 999, your container port is being forwarded to your base machine port 999. Okay, let's see if the port is open, then we will get the Apache test page. Okay, you grab the few. Okay, that's it. Here the 1.4 was a base machine, and the container running inside has a different IP. We can find the IP of the container by simply running docker inspect. Here is the container ID. And actually, if you run docker inspect, it will show you a whole lot of details. Okay, you can see what is the path of your supervisor dconf file, and what are the ports being exposed, and what is the host port. Okay, it gives you the lot of idea about actually what is running inside your container. Let's suppose I want to grab IP of that container. I do have just simply add grep IP. Okay, this is the IP of my container. But since I have forwarded the HTTP Apache port to 99 of my base machine, so it is running on this IP. Okay. This was actually this was meant to show you after, but you've seen it. Okay, first I was to show docker hello command. If you run want to simply run docker hello, how it will be run is like this simple. Docker run hello. Okay, this printed a message. As you can see, hello world. But this message got printed in my terminal of this machine. But this message ran inside the container. Okay, but since it was running hello world only, then the container started and executed the hello world and exited from there. You can check the status by running docker ps-a command. Okay, it will show you the status that it has been exited, and ran the command echo hello world. Let's run a hello world in a do while loop. Okay. Okay. Okay, as I have supplied docker run -d, this d will run this container in the background. If you want to check whether your hello world script is working or not, just you have to run docker ps to get the ID of that container. Okay, this was the container ID. You just write docker logs, paste the ID. Sorry, it's a typo. Okay, what I have done over here is that on my physical machine I have run docker logs and the container ID. Actually, you can, without logging inside the container, you can see what actually is running inside your container from your physical machine, from where it is running. Okay, this is our docker logs. Let's see our the image we are pulling is finished or not. Okay, it's still pulling. Okay, 107 MB, showing 1 minute estimated time. Okay, and we have shown you also an example of docker command with httpd. Now you might be thinking that how it is lightweight. It's taking time for loading PPT also. Okay. You might be thinking that how they are lightweight from the VMs. Let me show you the what I will do over here is in the demo that I have a virtual machine and I have a container which are being brought up by Vagrant. Vagrant, is a tool for managing VMs, and we can now, Vagrant has a new version. From that we can manage containers also. Okay, that will give you a proper idea. Okay, this is hello world. Is that finished or not? Okay, it's still going on. Okay, 5 seconds. Oh, let it complete it. Then we'll jump to that. Okay. Okay, it's complete. This is how you pull a container from a cloud repository. Okay. Let's clear the screen. Jump to demo. Let me what containers are running. Okay, if you want to stop a running container, just you have to write simple command docker stop. If you want to stop them individually, then just copy the container ID in front of docker stop and paste it. If you want to stop them in a group, then just paste the ID of other containers also in front of it with a space left between the IDs. Okay. Okay, a typo over here. I type decode. Okay. Okay, it stopped the container. Let's remove them. If they are of no use, remove them. Just simple docker rm command. Okay. We'll remove them in group. Okay. One thing I want to tell you that RM is for removing containers, and if you want to remove an unused image, you have to simply type docker RMI. I stands for image, and you have to each image. If you run docker images, docker images. Okay, each image has also an ID. Just you to write docker RMI and the image ID, or it will take also the name. It will remove the images also if you want to remove your unwanted images. Okay, coming back, let me show you why they are called lightweight. We have removed the containers. Okay. First, I will do a hello world in a Docker container, and then I will do a hello world in a VM. Let me show you the Vagrant file for that. Okay, This is our Vagrant file for managing Docker container through Vagrant. Okay, over here you can see as that we have given a name to our container and which specific image it will use to create our container, and the volumes, and this hash true is for just for used for provisioning, and this is a password, and this is we are using an inline script for provisioning echo hello world in that. Okay, let me show you how fast it is. You just have to type Vagrant up provider, as because provider is over here, it's Docker. Okay, it ran to hello Docker. It took, I think, 1 second. Okay, let's compare it with the case of VMs. This is our typical Vagrant file for a VM. Okay, we are setting on a host name over here. Again, with which box it will use for creating a VM, the box URL. It is a boot timeout. Okay, I have commented the network part, and this is for forwarding, and this is an inline script again using equal hello Docker. Let's see it. And we are given a RAM also 512. I will show you. Afterwards, you just have to RAM Vagrant up. See the clock, how much time it takes up a VM. It's progressing. It is just a base image, base VM. I have done nothing inside it. Again, okay, it's boarding the VM. Okay. Okay, if you are getting this warning because that after the VM has been started, it is running the set of startup services. So that's why it's showing warning connection timeout. In the case of our container, we don't have any startup services. It's just good to go. Just be with your watch and see how much time it will take. Okay. Grant, I think it probably took 15 seconds, okay, to run only hello doc. Now that's bring me to the picture. If we remove the VMs from our existing environment and place Linux containers instead of them. Okay, it's, the slide is coming, it's loading. Yeah, it's over here. So this brings me a picture of a conveyor belt. Okay, if we remove the VMs, okay, from the picture, and we have our containers over here. Let's see, there is a developer box at the end of the. This is a deployment conveyor belt. Okay, at the first end you have your developer box. In the middle of it you are testing, staging, and QA box, and at the end of it you have your production application, production server. Okay, and let's suppose developer does write some code, and traditionally what it happens, that developer came to staging, testing a QA server, and suppose in testing QA server you don't have any, let's suppose if it's a Java application and your Java path is not set in QA server, then what QA will do is that send the code back to developer saying that it's a bug. This actually increases the deployment time. Okay, but in the case of Linux container, you have, since it's lightweight and portable, what you can do is that once you are finished inside your container, you can ship the same container to the staging area, QA area. Then this will completely remove the mess that it works on my machine and why it's not working on your machine. Okay, then it will make the deployment process smoothly. This brings me to this picture. of DevOps, in which there are endless possibilities. You plan you plan your software, you do your coding, build it, test it, release it, deploy it, and you operate it and you monitor. This endless circle goes on, and it makes it easy to manage it through Docker also. So with this, we are done, and we do have a question session.
Can we use Docker to run untrusted code?
Yeah, you can use Docker to run untrusted code. You can use that, and you can see your bomb shell is good enough to bring the host machine or not. You can use that.
Can we do resource control in Docker?
Yeah, we can do resource control in Docker. They have documented it, and you can use CPU usage. You can restrict the access of memory and CPU utilization in Docker also.
How we just deal with the debugging in Docker?
You can deal with the debugging in Docker, as I have shown you Docker log, and if your Docker container is SSH enabled, then you can do SSH in it and see the logs, and this is the way how you deal with Docker.
Okay, good.
How can we run it on Mac OS and Windows?
Okay, I missed that part. We can run Docker in Mac OS and Windows. Okay, for running in Mac OS, they have a project boot to Docker. In that, what they do is that they first pull a base Ubuntu image and they run your Linux container on it. And similarly, in the case of Windows, what Vagrant does is that it will pull a Ubuntu image and make your Linux container inside it. This is how it actually works in the case of Windows and Mac OS. Because the container uses a Linux kernel feature, they will be required. So this is how you can use. Any more questions? Okay. So this brings us to the end. Thanks for coming and having your time. Thank you.